According to the 2002 National Electrical Code, specifically Section 334.15b, non-metallic sheathed cable, commonly referred to as NM cable, has specific installation requirements. This section addresses the protection of the cable from physical damage. The key aspect to consider is whether the drain pipe constitutes a wet location. The NEC defines a wet location as an area subject to saturation with water or other liquids. This could include locations subject to direct exposure to weather, such as rain, or locations where condensation accumulates. A drain pipe, by its very nature and function, is designed to carry water and is therefore inherently considered a wet location. Now, regarding the installation of NM cable in wet locations, the NEC is very clear. Section 334.15b stipulates that NM cable is not permitted to be installed in wet locations unless it is specifically listed and labeled for such use. This listing ensures that the cable's construction and materials are designed to withstand prolonged exposure to moisture without degrading or posing a safety hazard. In the scenario, the NM cable has been installed inside a metal drain pipe and secured with zip ties along its length. This installation method presents several potential problems. Firstly, the drain pipe itself can accumulate condensation or experience leaks, exposing the NM cable to constant moisture. Secondly, the metal pipe can potentially damage the cable's outer jacket over time due to vibration, friction, or expansion and contraction caused by temperature changes. Thirdly, the zip ties, while providing support, do not offer adequate protection against moisture ingress or physical damage. Because the drain pipe is classified as a wet location, and the NM cable is not specifically listed for wet location use, the installation is in direct violation of NEC Section 334.15b. This means that the installation is not only non-compliant with electrical code but also poses a potential safety risk. The fact that a licensed electrician performed the installation and that it passed an initial electrical inspection does not automatically validate the installation. It is possible that the electrician was unaware of the specific requirements for NM cable in wet locations, or that the inspector overlooked the violation during the inspection. Electrical inspections are intended to identify code violations and ensure that electrical installations meet safety standards, but inspectors are human and may occasionally miss certain details. It is crucial to understand that code compliance is not solely the responsibility of the electrician or the inspector. Anyone involved in electrical work, including homeowners and contractors, should have a basic understanding of the NEC and ensure that all electrical installations meet the applicable requirements. In cases where there is doubt or disagreement about the interpretation of the NEC, it is always best to consult with a qualified electrical engineer or a certified electrical inspector. These professionals have the expertise and knowledge to provide accurate guidance and ensure that electrical installations are safe and code compliant. To further elaborate on the potential hazards associated with this type of installation, it's important to consider the consequences of moisture penetrating the NM cable. NM cable typically consists of insulated conductors enclosed within a non-metallic outer jacket. If moisture enters the cable, it can compromise the insulation, leading to several risks. Firstly, the moisture can cause corrosion of the conductors, which can reduce their current carrying capacity and increase resistance. This can lead to overheating of the cable and potentially cause a fire. Secondly, the moisture can create a path for electrical current to leak to ground, resulting in a ground fault. A ground fault can trip a circuit breaker or ground fault circuit interrupter, interrupting power to the circuit. However, if the ground fault current is high enough, it can also cause a fire or electrical shock. Thirdly, the moisture can promote the growth of mold and mildew within the cable, which can further degrade the insulation and create health hazards. To ensure safety and code compliance, the NM cable should be removed from the drain pipe and replaced with an appropriate wiring method that is suitable for wet locations. Acceptable alternatives include using conductors and conduit, such as rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. These types of conduit provide physical protection and prevent moisture from reaching the conductors. Another option is to use cable that is specifically listed for wet locations, such as underground feeder cable or direct burial cable. These cables have a robust construction and are designed to withstand prolonged exposure to moisture without degrading. When installing wiring in wet locations, it is also important to use fittings and connectors that are rated for wet locations. These fittings and connectors are designed to create a watertight seal and prevent moisture from entering the electrical enclosure. In addition to the code violation, there are also practical concerns associated with using a drain pipe as a raceway for electrical cables. Drain pipes are typically made of metal or plastic, and they are subject to corrosion, damage, and movement. The NM cable can be damaged by sharp edges or rough surfaces inside the drain pipe, and the movement of the pipe can cause stress on the cable connections. It is never recommended to use a drain pipe as a raceway for electrical cables, as it is not designed for that purpose and can create safety hazards. If additional wiring is needed in an area, it is always best to install a dedicated raceway system that is designed for electrical wiring. This will ensure that the wiring is protected from physical damage and moisture and that it meets all applicable code requirements. In summary, the installation of an NM cable inside a drain pipe is a clear violation of NEC Section 334.15b. Drain pipes are considered wet locations, and an NM cable is not permitted to be installed in wet locations unless it is specifically listed for such use. This type of installation poses several safety hazards, including the risk of electrical shock, fire, and equipment damage. To ensure safety and code compliance, the NM cable should be removed from the drain pipe and replaced with an appropriate wiring method that is suitable for wet location. It is also important to consult with a qualified electrical professional to ensure that all electrical work is performed in accordance with the NEC and other applicable codes. It's worth noting that the NEC is updated every 3 years, so it is essential to refer to the latest edition of the code for the most current requirements. Electrical codes and standards are constantly evolving to reflect new technologies, materials, and safety concerns. By staying up to date with the latest code requirements, electricians and other electrical professionals can ensure that their work meets the highest safety standards and complies with all applicable regulations. Moreover, regular training and continuing education are crucial for electrical professionals to maintain their knowledge and skills. Electrical technology is constantly evolving, and it is important for electricians to stay abreast of the latest advancements in the field. This can include attending workshops, seminars, and online courses, as well as reading trade publications and participating in professional organizations. By investing in their education and training, electricians can enhance their skills, improve their safety performance, and provide their customers with the highest quality service. Additionally, it is essential to follow manufacturers' instructions when installing electrical equipment and materials. Manufacturers provide detailed instructions for their products, including specific requirements for installation, operation, and maintenance. Failure to follow these instructions can void warranties, damage equipment, and create safety hazards. Always read and understand the manufacturer's instructions before beginning any electrical work. Furthermore, it is essential to use the proper tools and equipment for electrical work. Electrical work requires specialized tools such as wire strippers, crimpers, and multimeters. Using the wrong tools can damage equipment, create safety hazards, and result in poor quality work. Invest in high quality tools and equipment and maintain them properly. Finally, it is always important to prioritize safety when working with electricity. Electricity can be dangerous, and it is essential to take precautions to protect yourself and others from electrical shock, fire, and other hazards. Always de-energize circuits before working on them, wear appropriate personal protective equipment, and follow safe work practices. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Remember, safety is always the top priority when it comes to electrical work. By following these guidelines, you can ensure that your electrical installations are safe, code compliant, and reliable. Consider also the specific application of the cash register receptacle. The NEC addresses requirements for receptacles in commercial settings. The type of receptacle, its grounding requirements, and its placement are all important for safety and functionality. while the focus has been on the NM cable and the drain pipe. Ensuring the receptacle itself is correctly installed according to code is equally crucial. This includes using the correct type of receptacle for the intended use, proper grounding to prevent electrical shock, and GFCI protection if required by the NEC for that location. Think about the environment around the counter area. Is there a potential for spills or moisture? If so, additional protection for the receptacle might be necessary, such as a weather-resistant cover or a recessed installation to minimize exposure. These seemingly small details can significantly impact the safety and longevity of the electrical installation. The use of zip ties to secure the NM cable to the drain pipe is another area for consideration. While zip ties can provide support, they are not designed to protect the cable from physical damage or abrasion. Over time, the zip ties can degrade due to exposure to ultraviolet light, temperature changes, and chemicals. As the zip ties weaken, they can loosen and allow the cable to sag or come into contact with the drain pipe, increasing the risk of damage. A more appropriate method of securing the cable would be to use cable clamps or straps that are specifically designed for this purpose. These clamps and straps provide a secure and reliable attachment while also protecting the cable from damage. They are typically made of durable materials that are resistant to environmental factors and can withstand the rigors of commercial use. When selecting cable clamps or straps, it is important to choose the correct size for the cable being installed. The clamp or strap should fit snugly around the cable without compressing it or causing damage to the outer jacket. It is also important to ensure that the clamps or straps are properly tightened to prevent them from loosening over time. Regular inspections of electrical installations are essential to identify potential problems before they become safety hazards. Electrical systems should be inspected periodically by a qualified electrician to check for loose connections, damaged wiring, and other signs of wear and tear. Inspections can help to identify code violations and ensure that the electrical system is operating safely and efficiently. The frequency of inspections will depend on the type of installation, the environment in which it is located, and the age of the equipment. Commercial buildings typically require more frequent inspections than residential buildings due to the higher demand placed on their electrical systems. In addition to regular inspections, it is also important to perform routine maintenance on electrical equipment. This can include cleaning equipment, lubricating moving parts, and tightening connections. Proper maintenance can help to extend the life of electrical equipment and prevent breakdowns. Another critical aspect of electrical safety is proper grounding. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. This helps to prevent electrical shock and minimize the risk of fire. The NEC specifies detailed requirements for grounding electrical systems. These requirements include the size and type of grounding conductors, the method of connecting to the earth, and the testing of grounding systems. It is essential to follow these requirements carefully to ensure that the electrical system is properly grounded and that occupants are protected from electrical hazards. Ground fault circuit interrupters, or GFCIs, are another important safety device that can help to prevent electrical shock. GFCIs are designed to detect small amounts of current leakage to ground and to quickly interrupt the circuit. This can prevent a person from receiving a dangerous electrical shock if they come into contact with a live wire. The NEC requires GFCIs to be installed in certain locations where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. It is important to test GFCIs regularly to ensure that they are functioning properly. The test button on the GFCI should be pressed periodically to simulate a ground fault and verify that the device trips. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Surge protection is another important consideration for electrical safety, particularly in areas that are prone to lightning strikes or power surges. Surge protectors are designed to protect sensitive electronic equipment from damage caused by voltage spikes. Surge protectors work by diverting excess voltage to ground, preventing it from reaching the protected equipment. There are different types of surge protectors available, including whole house surge protectors and point-of-use surge protectors. Whole house surge protectors are installed at the main electrical panel and provide protection for the entire electrical system. Point of use surge protectors are plugged into individual outlets and protect only the equipment that is plugged into them. Electrical fires are a serious hazard that can cause significant damage and injury. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and damaged equipment. To prevent electrical fires, it is important to have electrical systems inspected regularly and to address any potential problems promptly. It is also important to avoid overloading circuits by plugging too many appliances into a single outlet. Extension cords should only be used temporarily and should not be run under rugs or furniture. Smoke detectors are essential safety devices that can provide early warning of a fire. Smoke detectors should be installed in every bedroom and on every level of the home. They should be tested regularly to ensure that they are functioning properly. The batteries in smoke detectors should be replaced at least once a year, or more often if necessary. Carbon monoxide detectors are also important safety devices that can protect against carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be produced by appliances that burn fuel, such as furnaces, water heaters, and stoves. Carbon monoxide poisoning can cause serious health problems and even death. Carbon monoxide detectors should be installed in every home, particularly near bedrooms. They should be tested regularly to ensure that they are functioning properly. The batteries in carbon monoxide detectors should be replaced at least once a year, or more often if necessary. In conclusion, electrical safety is a critical concern that should be taken seriously by everyone. By following the NEC requirements, using proper equipment and materials, and practicing safe work habits, you can help to prevent electrical accidents and ensure the safety of yourself and others.